Alright guys, today is lesson 6.2, Residuals and Best Fit Lines. Alright, so this is task 1 if you want to follow along. Alright, so plot residuals. You can use the location of data points with respect to a line of fit to determine how well the line fits the data. The signed vertical distance between a data point and a line of fit is a residual. A residual plot is a scatter plot generated by the values of the independent variable and the corresponding residuals. To create a residual plot, create the residuals by fitting the difference of y's between the actual y value and the predicted y value for each x value. Then plot the residuals. Alright, so you can see here, this is given x2, so here's our x value. And this is the predicted point because it's on the line. And then this is the actual point. So the residual is the difference between that. Okay, so you can see they're doing y2 minus this y2 with the little caret on top. All right, the following plots show how residuals may be distributed from 3 data sets and lines of fit. All right, so if you look at this one, they have a line here. I'm guessing that this just kind of goes up and down. So the left plot, the distribution of residuals, is random and tight. The line fits the data very well. So I guess they're saying this line here kind of represents this set of data because it's just randomly going up and down above and below it kind of equally, that it fits the data well. The middle plot, the distribution of residuals, is random but loose. So it's got one here, a couple down here, one on the line, but 2 up here and 1 down here. So it's not very closely aligned here. So the distribution is random but loose. The line fits the data but weakly. Okay, so not strong but a weak correlation here. The right plot, the distribution of residuals, is tight but not random. Okay, the line does not fit the data well. So here it kind of goes like this one would be better if the line kind of went downhill and kind of went through these points at an angle, like a negative slope would be a better fit for that one. All right, so it says the table shows the mean, that's the average, height, and girth. Girth is your circumference measurements for a Douglas fir tree in a mountain range. A line of fit for the data is y equals 0.04x plus 2.32, where x is the height and y is the girth, both in meters. All right, so you got the height and the circumference again. Girth is just circumference. So the height and the circumference of these Douglas fir trees. All right, so it says using a spreadsheet, create a table like the one shown. All right, so what we're going to do is take the equation and find out what the predicted value is by simply plugging in the x. So if you look right here, they gave us this predicted value here, and they're saying the equation is 0.04x plus 2.32. So what I'm going to do is try to use this equation. And instead of x, I'm going to replace it with 60 plus 2.32. So again, I'm just taking this equation and I'm substituting a value in for that. So if I do that, I'm going to get 4.72. All right, so if I come down here and I'm looking at my table, my predicted value is 4.72. And I got that by simply plugging this x value into the equation. So 4.72. And my actual value was 4.83. So to find the residual, I just need to subtract these two. So 4.83 minus 4.72 is 0.11. All right, so you need to do that for each one of these in the table. So just pause the video and go ahead and fill these in. All right, guys, hopefully you paused the video and took time to fill out your table. Again, all you had to do was take the equation and substitute x into the equation one at a time. When you did that, that gave you your predicted value because this equation is our equation we found for the set of data. And by plugging in the x's, it's going to give us the y value. So that's our predicted y value. To find the residual, all you had to do was take the actual minus the predicted. So 4.83 minus 4.72 is 0.11, so on and so on. You can see here at the bottom, 5.04 minus 5.04 is just 0. So all we did was subtract column B, or subtract column C from column B here. All right, to complete the formula to find the predicted y value in cell C2. All right, so in C2, all we had to do, this just wants the formula, so it's 0.0, I guess we better put the 0 here, 0.04 times A2, which is 60, so times the 60 plus the 2.23. All right, so A2 is just whatever's in that space. A2 and A2 is 60, so we just plugged in that x value to find the y value. So that's just showing the formula that we used. To determine the residual in cell D2, what formula do you use? All right, we did B minus C. So B minus C. And it says, fill down the formula in cells from C2 to C10 to find the predicted values. Fill down the formula to find the residuals. Okay, hopefully you took time to do that above. If you did not, now you're going to have to enter these to see what you got. So, let's see here. I know most of mine, 4.72. And this was 4.76. 4.8. 4.84. 4.88, and again, this comes from plugging this x into your equation. Make sure you know how to do that because you will have to know how to do that come test time. Just watching or copying what I'm doing does not really make sure that you know what you're doing. You have to kind of do it on your own. All right, once you do that, then to find the residual, you just subtract. So this is going to be 0.11. This is 0.34. This is 0.13. 0.31. All right, so the only question I may have is I don't know if these need to have a 0 in front of it or not. I did not put a 0 in front of there, but let's check it. Okay, so it took it just how I had it. So again, you find the predicted by plugging the x into the equation. You find the residual by subtracting predicted from actual. All right, it says use a graphing calculator to graph a residual plot of x values and residuals. Describe your graph. All right, so what I would do is just graph my ordered pairs on here and then look at the table of best fit. So if you turn it on, let's clear this out. Go to Stat. Edit, I've already got points. I'm going to do second plus 4, clears out my list. Go back to Stat, Edit, and then I'm going to just enter my points in. So I'm going to have to go back up to my table here. And let's see if I can quickly do this. So 60, 61, 62, and then put your Y's. All right, again, always kind of check and make sure that you have entered these correctly. And that way you get good information from your graph. All right, I'm going to go to Graph. This still has my equation in it from the last one, so I'm going to clear this out. I'm going to go to my window. And I'm going to have x's from 60 to 68. So, let's see if it'll let me put a minimum of 55 in here. I don't think it will, but we'll try it. Okay, my y's go from 4.5, so let's say, let's go from 4 up to 6. Let's see if it'll let us do a scale of 0.25. Enter. All right, so it did let us do that. And this is my cluster of points here. All right. All right, so let's describe the graph. So let's put the equation in as well. So if I have an equation, my equation was 0.04x plus 2.32. So I'm going to put in 0, 4x plus 2.32. And then hit graph. All right, so you can see that that is a good equation for this set of points, even though there's some on both sides. That's kind of the best indication, the best line of fit that you can kind of get, let's say. All right, let's see what the questions ask for very quickly. We're running out of time here. All right, choose the word or phrase evaluated, the quality of fit. All right, so the line fits the data. I would say very well. The residuals are not about the x-axis. So if you look at that here, you can see they're not really around the x-axis. If you have any questions,